In the last two videos, you've seen the mechanics of declaring, assigning, and dereferencing pointers. But we haven't really seen why pointers are useful, and they are incredibly useful. I hope that by the end of this video, you understand why. Suppose that I submit an assignment, maybe a C program, that earns a B. Let's print out that value. But unfortunately, I was a little careless and missed the deadline, and so my professor applied a late penalty, and my mark of B is lowered to a C. Let's print out that value. Notice, by the way, that applying the plus plus operator to a char increments the value of the char by 1. And since our ASCII codes for the letters of the alphabet are in order, grade Michelle plus plus evaluates to C. That's all fine. Felipe was also late with his assignment, but he started with an A. Since lots of students are late, it makes sense for us to create a helper function to apply the deduction. We call our helper function applyLatePenalty. It has a void return type, which means that it won't return a value to the calling function. The only parameter is a char named grade. To apply the late penalty, grade is incremented by 1. This is the same as what we did earlier to Michelle's grade. So if grade is A, it will become B, B will become C, etc. Oh, but what about F? Once someone has an F, the late penalty doesn't change anything. Let's add an if statement to handle this. Now let's change our main to call the new function on both Michelle and Felipe. And let's print out Felipe's original grade and his adjusted grade. Now when we run the code, what do we get? What happened? Let's consider the case when we call the function on Felipe. Remember that function parameters are local variables in the stack frame of their corresponding function. They are assigned the value of the calling argument. So in this case, grade within the stack frame for applyLatePenalty is assigned the value A. Then it's changed to be B inside the function, but this has no effect on the argument that gave it the initial value. You might decide to fix it by returning the updated value, but then we'd have to assign the returned value to a variable. Instead, we can use a pointer to change the value directly. I'll make a copy of our function so that you can see both the correct and incorrect version. Just for clarity, let's change the name to reflect that the parameter is now a pointer. Now we need to dereference grade pointer to access the grade before we compare it to F. And dereference it here too before we increment it. And we need to worry about order of operations. We want to increment the dereferenced value, not the pointer address itself, so we need the dereference to happen first. We'll use parentheses to force this operation to be first. The function looks good, but now we need to pay attention to how we are calling it. Let's leave Michelle using the old incorrect function and have Felipe use the new one. Our new helper function is expecting the address of Felipe's mark, so we need to use the ampersand operator in the call. As you can see, the value for grade Felipe is being changed. Before you continue to the next video, it's very important that you understand how to use a pointer as a function parameter, so that from inside a function you can change a variable that's stored outside the stack space of that function. I strongly recommend that you download the code that we just used in this video and step through it in the visualizer, and then do some exercises that practice these ideas in code.